thought this was encrypted UHF. I'm out.
No! We can get there. We can do that.
Encrypted VHS.
Right, this is about VHS, according to the program.
Are you encrypting data onto a tape and then playing it back?
No, I'm encrypting analog video onto a tape and playing it back. This talk is about macrovision. No interested in that.
Do I need a Amiga toaster for this talk?
No, but you do need an Apple II. Fuck. An Apple II, not a 2E. That fucks everything up. This code was hand optimized just for the 2.
Apple One. Praise Steve.
I'm good?
Yeah.
Praise Steve? Okay. Okay, hey everybody. Oh.
Hi!
Slightly
Nothing's
different.
happening.
Okay.
You can turn them off.
Before I start, I have like one thing I need everybody to do me for.
Drink!
That better be vodka and water.
We're really wishing happy birthday.
Whose birthday is it?
I bet I know whose it is. Birthday? You just drinking.
Happy birthday to who?
Okay.
To my very close friend. Not you. Will Pig. It's Will Pig's birthday. If everybody could just tweet him at Will Pig, like happy birthday from Rog, PhreakNIC 18, it would mean a lot to him. You don't have to do it. Oh, yeah, you have to do it right now. Okay. That's good. We can wait.
I'm doing this.
Thank you, guys.
I don't even know how to do it, but I'm doing it.
I really appreciate it.
Somewhere enough to tweet.
What is Tweeter?
Tweeter is what you use your encrypted VHS tapes for. This is going to be a thorough talk. I hope you guys brought notebooks. I'm going to pass out quiz books at the end.
I thought this was the video box.
Okay. Guys, it's just 140 characters. Half of them I gave to you.
Is there a hashtag for PhreakNIC?
Yeah.
Barrett! Oh, it's really small. You can't read it. You can't read it.
I can't.
It's
hashtag
PhreakNIC
18.
It's a long tag because this is a long
How do you
comment.
spell FreakNIC?
Wait, I'm gonna take a picture too.
P as in Peter, H as in Henry, E as in eat,
You forgot the R, but that's okay.
A as in alpha,
A is in K.
K as in K, N as in night, I as in igloo, and C as in cat.
Very good.
What?
Night starts with a K.
Exactly. Okay, moving on. Thank you. Assuming y'all actually did it.
I did. Or did.
We either did or we didn't.
That's true.
Keep talking.
So, I'm Nog. Hi.
Hey there, Bob.
I play with hardware stuff a lot. It's lots of fun. Electronic stuff. People should do it. Make things. It's cool. I'm also an amateur radio guy. Any other people hands in here? Does anybody actually broadcast? Like, raise your hand if you ever. Wait. Second question. Does anybody actually broadcasted? Like, ever?
Legally or illegal?
Legally.
Yes, sir.
Okay. That's awesome. I've never broadcast on the handbands.
True story.
True story. I'm also a free software zealot. That's why I can't give this presentation on my laptop, because I couldn't get the video working. And I'm sorry. That'll come up later. So I guess a lot of people don't know a whole lot about RF here, because it's black magic. This thing. There's like a coil here. This is where the magic happens. It goes to ground.
It's so sexy.
I don't understand.
It is. Like I said, magic. So this is like the simplest way. Oh,
Those PMs are fucking
it was a gift. So imagine this sine wave was going up and down. That. Okay, so this was like an AC signal, and it's just going up and down. And this signal, the amplitude wave, is going up and down to match the signal. This is what's called AM signaling. So the frequency we are broadcasting on is the length between peak to peak. And that's like what like 96.5 megahertz or whatever. That's the frequency you're on. And then the amplitude is actually how the information is sent in this. So like you raise the power to go high, and you lower the power to go low. So like a high would be like a 1, a low would be like a 0. But it's analog, so it actually is, it's like a record player, it's anywhere. And then the other type is called FM modulation, it's frequency modulation. And so in this, the power is constant, so the waves are in a steady stream, and the bandwidth actually fluctuates. So you like pick a start frequency, but the actual width of the channel you're taking kind of changes a little bit. But that's kind of all you need to know, because like I said, it's all just black magic. If you kind of understand it like that, you understand radio more than 90% of people. So like I was talking about, spectrum is just this. So this right here at the very top, that's 0 hertz. So that's just like a DC current, like just on. All the way down to 300 gigahertz is what the top end of the spectrum that the government regulates. So everything from 0 to 300, the FCC says we own it. And what this chart actually describes is how they break up each section. It's really big, it makes a really good poster for your wall. But each of these different colors represents like who's allowed to use the spectrum. And in this talk, we're talking about VHF radio. So in particular, it's just the 30 megahertz to 300 megahertz. Very high frequency was defined back in like forever ago. So 30 megahertz was really fast back then. And so that's what that is. And in particular, we're talking about this small subset. And here, these fixed positions are what is currently licensed as the MERS bands.
Can you make that bigger?
No.
Probably not.
Let's see what happens.
Enhance.
You have to pay extra for bigger.
We're doing it. No.
Oh!
Got some more.
That's alright, I forgive you.
Okay. It's just these little purple lines. I'll explain more in a second. So MERS stands for Multi-Use Radio Service. It was defined in the year 2000. So a lot of people don't know about it. It's new by radio standards. And it's a few channels. So these channels, so it's starting at 151.82 megahertz for 11.25 kilohertz. That's a channel, and then so on for these others. And
Blue dot, green dot.
oh, okay. So these two channels, you notice, are like twice the bandwidth. So these are called ultra narrow band. So 11. How to explain it? So a standard, like when you're on the phone and a voice phone call, you're speaking on an 8,000 kilohertz channel.
Right.
So this is a 11.25 kilohertz channel. So it's slightly wider, but given radio issues, it doesn't sound as good. Whereas a 20 kilohertz is even wider. You have more space to put the information of your voice, so it sounds better when it gets to where it's going. So in particular, these two channels, the blue dot and green dot, are typically reserved for voice communication on this system.
Why do they call it blue dot, green dot?
I have no idea what it is. I've read the things, and some guys like blue dot, green dot. I think they put them on some of the radios to begin with, and it just kind of stuck.
Okay.
If somebody else actually knows, I would love to know, because I have no idea why they did that.
Okay.
So yeah, these frequencies you're allowed to broadcast on at up to 2 watts. And the other restriction is you can only have a tower of 40 feet tall or 20 feet on top of a building.
That's 2 watts with a license.
No. So where is MERS? We're going to get to that. Where is MERS? It's only currently in the United States of America. In 2014, this year, in June, it was supposed to come to Canada, but at the last minute they were like, no, we don't need to do that. And they put it off till August. And then in August they said, this is a lot of work, and it's kind of delayed indefinitely. But the really sneaky thing about it is you can really use it anywhere because it's only 2 watts. Your typical range is only about 10 miles. And given the frequencies it's on, there's nothing in that spectrum currently in Canada or America, so you're not likely to smash on anybody. And so people tend to not care. I've noticed when I've been scanning around in different places, certain people breaking the rules, and I've never heard of anybody getting busted for this. And particularly one of them was a hospital. They don't seem to care.
I don't understand that.
So who can use MERS? Everyone! Woohoo! It's unlicensed.
Freedom.
Anyone can use it. There are only a few restrictions on it based on like what I was saying before, that you can only broadcast at 2 watts, you can only go so high, and a few other stipulations that are listed on. So it's really awesome. Anybody can use it. No training needed. So how can you use MERS? There are a couple of easy ways to get started. There are some modules, like this is a walkie-talkie module you can build yourself, and it allows for hitting those 5 channels and broadcasting or receiving. There is a great little ham radio that can, like I was saying before, it's not legally allowed to be in MERS because it's a 5-watt radio, but it can tune to the frequencies, and
They just came out with 8-watt.
you're not, well, I guess you could even go to 8 watts then. But it's within its frequency band, so it's trivial to broadcast or receive from that as well. If you want to be completely legit, Motorola sells actual MERS radios, but they are 3 times as expensive as the Chinese radio, and they work just as good.
How much is the Chinese?
$34.
Yeah, like $34 to $50 on, depending on where you get it from.
$34 Amazon.
It's $34 Amazon Prime?
Yeah.
Amazon Prime? What a bargain. Please click my referral link in the notes. The other project, this is what actually got me interested in MERS to begin with. There's a company called GoTenna. They almost have a real product out there. They're going to sell these little radios. You connect them to your phone over Bluetooth Low Energy, and they come 2 in a pack, and they're set up to do text messaging between the phones over this network, and it uses AES encryption, and it's really nifty, but they don't have FCC approval yet, and they haven't had FCC approval in the 6 months that they've been almost selling them. So I would say pre-order, but maybe not. I haven't. Yes?
Is that like text message over APRS?
No, it uses the MERS. So the MERS protocol, like I was saying, you have those 5 channels. You're allowed to do data over those channels. You're allowed to do data in any format. So I don't know what they're using. They could be even using like RIDI, but they're doing something to transmit the data. And on the phone, before it sends out the data, they're AES encoding the strings so that only the other pair can read it. And then they have some other like nifty features, like they have like a help me feature where you can like broadcast to anybody that owns a GoTenna, and it's not encrypted, saying like I need help, or I have donuts in my apartment, come get them. Like, I don't know what you would want to send a mass group of people, but they're nice. I don't know. I would get one maybe. Why should you use MERS? There's so many other options out there. MERS is the only citizen band that allows you to do encryption. So GRMS, CB, the ham bands, FRS, etc. If you want to be in private, you can't use them. On the ham bands, you're allowed to talk encrypted to a robot, but if you're going to talk to anybody, you can't. There's some, in the ham bands in particular, there are a lot of like fancy radios that like do channel hopping and try to do some like inversion things to like obfuscate the signal somewhat, or they use like the D-star encoding, so then you need a D-star radio to encode it. But all of them explicitly are not allowed to encrypt. So anyone with any time could start listening in on all your conversations with whoever. So unless you're talking to other radio people about the radio, probably not a good idea to talk on the ham bands about anything private. Another good thing about MERS is it's low power. So you're maxed out at 2 watts, but the spectrum that they're in, the VHF, the way it bounces off the earth allows you to get around 10 miles with it. So unlike like Wi-Fi, for example, which is a few hundred feet, you can actually get from like one end of town to the other if you have good placement.
Without a repeater?
So I'll get to it in a second, but MERS are actually one of the few rules they have is you're not allowed to use a repeater.
Okay.
But if you have a 40-foot tower at your like home, your base station, I would expect you to get several miles away from your house, even without line of sight on the station. one thing I've liked about it is so far MERS has not been very popular because radio manufacturers haven't targeted it so much. Like the Motorola and 2 other radios are the only ones I know that are actually MERS branded radios. Everyone else just does MERS because they can. And so because of that, there's very little traffic on the bands. So like in particular, when I got here at the hotel, I scanned the band from here at the hotel, and I found one person transmitting data, but the other 4 channels were free the whole time we've been here. Nothing on it. And so as long as everybody here doesn't start using it, it'll be okay. The other thing is it allows data and voice. So some of the other citizen band don't allow data, and that's annoying because I want to talk to people digitally, and I don't really want to ever talk to people in person.
Are you talking to people digitally through a Bayo thing?
You can. One of the things I'll get to in a minute is there's a guy that modified the Bayo thing to talk to an Arduino and to talk radio over it between his 2 stations.
Awesome.
So why shouldn't you use MERS? Small bandwidth. So each of those channels you saw, they're like 11 kilohertz to 20 kilohertz, which means if you're going to do data, you're maxing out at around 14.4 kbps. So you're not going to browse the web anymore from it. You're not going to download images, no YouTube, lots of other things. They're just not really feasible. So that kind of sucks. It's yet another radio, so like it's not going to be in your phone, it's not going to be in your laptop, it's going to be some other device you have to have. So that's another reason that you might not want it. And one of the big problems with it is they're legally not allowed to cluster or relay messages. However, you can encrypt the messages. So I don't see how they could stop you from doing that, or know that you're doing that, as long as you're changing the bits as they move around the network. But don't do that. It's against the rules. The other thing that's kind of like a holdover is you're not allowed to patch telephones into the system. So you can't use it to like supplement cell phone service. Huh? Yes, you could do it if it was encrypted, but like I was saying before, your bandwidth is small. It would be difficult to do it with data. You might be able to do like some kind of voice encryption and pull it off, but you shouldn't because it's illegal. And like I was saying before, there's very few hardware devices that support this, and there are even fewer software packages that do anything with it. So you're an early adopter. And the other thing is it's banned on airplanes. Don't use VHF radios on airplanes, ever. You will kill everyone. Repeatedly. I think you only kill them once. They don't respawn. So this is where I was going to have my demo if I had my laptop. I think I can. So what I was going to show. So I was going to show you this piece of software. It's called GNUradio. It's a package that kind of uses some of the GNU radio stuff. And what it does is it shows you a spectrogram and frequency waveform of what you can see with your like radio equipment. So in particular, at this hotel, at like the 151 channel, you can actually see like this data stream coming by, and like it's like talking, stops, talking, stops, and it just like sounds like a modem. It's over and over again, and it's kind of cool. I haven't decrypted it to see what it was, but then the next step, what you would do if you were going to do something with it, is you can come over here, you dump like the sound file into Audacity, and you can actually see the waveform, and then you can try to like start trying to figure out how they encoded the data and do something with it. Because even though you can do encryption, from what I found, no one does encryption on MERS currently, although they should because it's there for everybody to hear. So back to where I was. So Open MERS is this project that I've been working on. I have one of those MERS radio modules, and I have it hooked up to a Atmega 32U4, and I am setting it up to do just a simple RIDI modem that you can control from your PC. So currently it's like a 9600 serial baud device that you can just pump any data into. I would recommend people only pump encrypted traffic into because there's no reason you should be broadcasting in the spectrum. Unsafe. and you'll be able to listen. You'll get 9600 baud back out, but it's not completed yet. The other thing that I wanted to have a feature for is to also expose a sound interface so that you could actually broadcast audio over the 20 kilohertz as well. But I haven't even begun to play with that yet. But once that's done, I hope to have something like the Go Tenant where you can attach to your laptop and broadcast to it from a base station and use it more frequently. Hopefully I'll have it all working this winter. I meant to have it all working for here, but I have a baby. A little baby. It takes a lot of time.
Just one.
Just two. The project that I was talking about before, here, if you go there, this guy has hacked up a Baofeng radio so that he can drive it with an Arduino. And he already has this working where he can send data over RIDI and read it back over a serial line on his machine. So he can transfer data from it. And it wasn't too hard. He had to solder 16 wires on the Baofeng out of the case, and it worked pretty well. So that's what you should check out if you want to play with it. That's the Baofeng hack that you can do data with.
Okay.
So if you want to get started with this, one of the first things I recommend anybody that wants to get started with radio stuff is this device called RTL2832U. This is the little TV tuner card that everybody that starts with radio stuff does. The nice thing about this E4000 one in particular is it has the best range of frequencies out of all the little USB cards. The other nice thing is the antenna port on it is a POW female adapter as opposed to an RPSMA or other type of connector. So it's easier to get an antenna connected to it and actually receive good signals. It's very cheap. This is $30 or less.
Can you see 900?
You can see from, I think on this one, you can see, I want to say 40 megahertz all the way up to 1400 megahertz, and then there's a gap at 1400 to 1500, and then from 1500 to 2.2 gigahertz.
Pretty good though.
And the bandwidth you can receive is 2 megahertz wide. So you can see for example the whole MERS a whole MERS channel and more, and very easily be able to find it. And so this is what I got started with. I think everybody should get started with it. It's awesome. The next step up is this device called the HackRF1. It was made by Michael Scott not Michael Scott, Osmond. From Great Scott Gadgets. It's a really great device. It is a more beefy radio, and it's a lot more expensive. It's $300. But the nice thing about it is it goes from 10 megahertz to 6 gigahertz with a bandwidth of 20 megahertz, and it can transmit. So once you get going, you can actually start transmitting to your own hardware and seeing both all sides of it control. And you know that at least this device is doing exactly what you think it's doing, because it's all software. There's nothing in hardware to screw up or solder incorrectly or whatever. It's just much easier to work with. The other thing is this is the module that I'm using to build my device out of. It has a serial control, so you can talk to it and tell it what to do and how to configure itself for the channels you want to use. It has mic input lines. And the nice thing about it as well is it's designed to be like a kit to make your own walkie-talkie. So before you really get started, you can actually hook up a speaker and a microphone to it, and you can use it like a walkie-talkie and really understand that it's working and change frequencies and see that that's working before you get into where it's all digital. And because you wanted the Ultra, they have another version that's ultra high frequency instead of VHF.
Nice.
But you can't talk encrypted to the ultra high frequency band on any of the channels, so it's worthless. The other thing I'd recommend people get is a microwave oven, preferably a dead one. They make great Faraday cages, and so when you're experimenting with this stuff, it's really easy to have the USB cable go into the microwave, have the other device go into the microwave, shut it, and then you see no other signals. They pretty much block out everything to a large degree. It makes it a lot easier to tell what's going on. And I doubt anyone here has, the $10,000 EE room that has the Faraday cage. You can get a broken microwave for nothing. So I would do that. I have two. The software you want to use, GQRX is a great place to start. If you download the software and you have like that USB dongle I was talking about, you just tell it, use the USB dongle, and then you hit the go button on it, and then you immediately start seeing spectrum. You can slide the slider back and forth to like listen to radio stations, for example. You can usually hit like the weather radio for your town. Lots of stuff. It's just real easy to really immediately see stuff work, which is a great feeling. And it's also just good, like when you're testing your equipment, you can actually see the radio waves in real time and tell if they're corrupted or you're getting interference. The next big software that's really hard, it's called GNUradio. It works kind of like MATLAB or another like suite, a coding suite where you're just building blocks and connecting them to do things. It's really high level, but it's where you kind of go next. In here, you can build modems and services. Like, for example, if you guys are familiar with the GSM base stations they've made, the open source ones, the main project, the one I'm familiar with, is actually built on top of this stuff to begin with. And so you can build really complicated things in here. Audacity is a really great sound editor. It's really good to just like take all the bandwidths of the stuff that you're kind of playing with are small enough. They're less than 44 kilohertz, so it's really easy to just listen to them and kind of get a feel for what they are. And in Audacity, you can filter out things very easily. And so it's really a great place to start too. Best place to ask questions, in particular, are #hackerf and #RTL SDR on the Freenode. They're real friendly people there. Help you out with anything you need. Everybody should be on Freenode if you're not right now. Questions, comments, thoughts? Yes.
What radio are you using now?
So I use the RTL for usually for verifying things, because I'm also using the HackerF and the module. So, for example, I'll have the HackerF like mirroring things I'm seeing from the from my RF module, and so I have those two like talking in a loop, and then I can use the smaller radio, the RTL device to see that spectrum unimpinged. And it's nice too. Like I have an RTL at my house. Always plugged into one of my computers, and one of the problems with the submerged stuff is, so like the radio module that I use, it broadcasts at 1 watt no matter what. And so if you have if you're working with the two radios and they're in like feet of each other, 1 watt will flood out your other radio. So it's nice to have some distance. So like I can be working at a shop on this, at my make shop, which is a mile or so from my house, and I can see it all the way at my house. The software allows you to work with it over the network. And so it's nice for that. But I mainly use the RTL dongle, the HackerF, and that module that I own right now. I have used the Baofeng to like verify things, worked in the past. Some of my friends own Baofengs, but I don't know one person.
Do you do anything with GPS capabilities?
With GPS? No, I haven't done anything really with GPS. I know that there are some projects to bring GPS to GNUradio, like to do it just in software. But currently, to my knowledge, there's only one project that's done GPS outside of a package solution, and it was like 3 FPGAs and some other stuff to do it all. And I think the government frowns on you doing that because GPS is built. The way you like get a license to build a GPS radio is that you agree to have it not work when it's over 20,000 feet and not work when it's going Mach 3. So you can't build a missile. And if you built your own GPS radio, I doubt you would put those constraints in, even if you were a friendly guy. You might leave those out. But I haven't played with GPS really. Anybody else?
All right, thanks a lot. No problem.